to maintain that field. So in other words, we're getting into why does the Earth spin? How is it generating this? And okay, so this is, and it's saying that in an electromagnetic you need a current to keep it going. And if that current stops, the magnet stops. So if there's an iron core in an electromagnet and you don't have any current going, all those iron core domains, they call them, point in all random directions. They don't all line up without a current. They're just randomly all over the place. And they do have tiny magnetic fields, but they each cancel each other out in that situation. So it's not really anything that's no large scale. But when you pass a current through the wire wrapped around the iron, then its magnetic field penetrates the iron and causes all the domains to turn, aligning parallel to the magnetic field. So their tiny magnetic fields add together to the wire's field, and it creates a large magnetic field that extends into space around the magnet. And again, when it's iron that is in there, because this can happen with just air around a coil, but when it's iron, it increases it thousands of times the strength of the field of the coil alone. So without that current though, the iron just fragments and it's just little tiny fields that don't add up to anything. When you put the current, they zoom in right away. And when the current is turned off, they return back to their random state. This phenomenon has a name. It's called hysteresis. And the remaining magnetic field is called remnant magnetism, what's left when you turn the current off. There was a Danish scientist, his name was Hans Christian Ørsted. He discovered in 1820 that electric currents create magnetic fields. And he invented the electromagnetic magnet in 1824. All right, so I've already really hammered that. But I had this from many different sources and I kind of pieced this together and added it up. So when we learn about these things, it raises new questions to our scientists today. These are questions they don't have answers for. The liquid iron must be the source of Earth's geomagnetic field, called the Geodynamo. But how does it work? Why does the Geodynamo flip, switching magnetic north and south over geologic time? What happens at the top of the core where molten metal meets the rocky mantle? Answers began to emerge during the 1990s. After all this time, they just discovered this information about magnets in 1820. They just started getting answers in the 1990s. And they still don't have them all. In 1996, two people named Xiadong Song and Paul Richards confirmed a prediction that the inner core rotates slightly faster than the rest of the Earth. The magnetic forces of the Geodynamo seem to be responsible. Core studies surged in 1996 when they put this to computer models to find out, and they reproduced the behavior of the Geodynamo, including spontaneous reversals. Hollywood actually made a movie out of this called The Core. In the movie, the collapse of the Earth's magnetic field is inexplicably signaled by failing cardiac pacemakers. Okay, these are the things they predicted would happen with the electromagnetism of the Photon Belt, that pacemakers would stop working, people would have heart attacks, not even with a pacemaker, just because our hearts are electrical. Same thing as if you were struck by lightning type thing. And a space shuttle's thrown off course, perhaps because it was steering by a magnetic compass. This is in the movie, The Core. The wandering of the northern lights went to lower latitudes. Without a magnetic field, there would be no northern lights at all, because what those are solar flares that are attracted to the magnetic field of the Earth. They show up only where the magnetic field of the Earth is. And if you were following the news last year, you might have heard that the northern lights were appearing in Texas. Did anyone hear that?
Yeah.
They were coming down as far south as Texas. Mm-hmm. They only appear where the magnetic field is. So this is telling you the magnetic field is moving south. So in the movie, they had the Earth's magnetic field collapse, and in the movie, it was because the Earth's core had stopped spinning. So, did anyone see this movie?
Mm-hmm.
I believe they tunneled down into the center of the Earth to try to get the inner core spinning again. Okay, so for at least the last 160 million years, as known from evidence preserved in the geological record, Earth's magnetic field has often reversed polarity. In the last 160 million years, they see this evidence, which is tiny magnetic domains that are in layered basalts on land, which is lava, rock that comes from lava, and on spreading ocean floors frozen in different orientations, in different layers. They can tell, that's how they can tell where the polarity of the Earth has been in the past. But the core spin of the Earth is not implicated in this evidence. The solid inner core turns only once every 120 years or so, relative to the rest of the planet. That's how often the inner core actually reverses its polarity, is like once, or turns only once every 120 years. No one knows the real reason for field reversals. And most magnets are made of iron. In fact, we have iron in our blood, in our red blood cells, which is tiny. It has a tiny charge. It is slightly magnetic. That's why you see the magnetic therapies people are trying to work with to increase blood circulation by putting those on, attracting to the iron in our blood to move the blood. So, in what ways are electricity and magnetism alike? Does anyone know? What?
Both can be conducted.
Conducted?
Yes.
Okay, meaning what?
Meaning they can be conducted by an element or mineral.
Okay.
Like a current can be passed, or a current can be made of that type of energy.
Either magnetic or electrical?
Mm-hmm.
All right, so both electricity and magnetism both produce a force that can pull or push things without touching them. We all know magnets can do that. Electricity can also do that. They both have opposite states. Electricity has positive and negative, and magnetism has north and south. And in both, opposite states attract and the same states repel. That's what's common in electricity and magnetism. The Earth's magnetic field is mostly caused by electric currents in the liquid outer core, which is composed of highly conductive, as you said, molten iron. A magnetic field is generated by a feedback loop. The current loops generate magnetic fields. A changing magnetic field generates an electric field, and the electric and magnetic fields exert a force on the charges that are flowing in currents. Magnetism can produce electricity, in other words, only if it is accompanied by motion. It has to have motion for magnetism to produce electricity. And I know I'm just like really hitting this part hard, but it's almost over, and then I'm going to ask you some questions. So the mere convective motion of an electrically conductive fluid is not enough to ensure the generation of a magnetic field, however. The above model assumes the motion of charges, such as electrons, with respect to atomic nuclei, which is a requirement for generating a magnetic field. However, it is not clear how this motion of charges arises in the circulating fluid of the outer core. Possible mechanisms may include electrochemical reactions, which create the equivalent of a battery generating electrical current in the fluid, or a thermoelectric effect. However, unlike the field of a bar magnet, Earth's field changes over time because it is generated by the motion of molten iron alloys in the Earth's outer core. The key is that the Earth is constantly spinning, so the liquid iron is constantly moving as the conductor and generating electricity. And once you have currents, those give rise to more magnetic fields, which cause more currents and cause the magnetic field to rise. At random intervals, averaging several 100,000 years, the Earth's field reverses, which means the north and the south switch positions. These reversals leave a record in rocks that allow paleomagnetists to calculate past motions of continents and ocean floors as a result of plate tectonics. And it's recorded in sedimentary rocks. Changes over time scales of a year or more mostly reflect changes in the Earth's interior, particularly the iron-rich core. So they're still saying it's all based on that interior iron core. And these events, which are believed to last a few hundred to a few thousand years, where the Earth, North and South Pole are interchanged, often involve an extended decline in field strength when they're about to occur, followed by a rapid recovery after the new orientation has been established. They say that it only takes 24 hours, in other words, for a North Pole to switch, and where the South is where your compass would be pointing to from now on, instead of the North Pole. Your compass, would point to magnetic south, is what it would, that's what a pole switch is. And again, evidence of these can be found in the basalt sediment cores taken from the ocean floors and seafloor magnetic anomalies. We know that this has happened tens of thousands of times since the Earth's formation in Earth history. Okay, so this has happened tens of thousands of times. It happens all the time, and every time it has happened, they always see this decline in the field strength prior to it happening. The weakening of the Earth's magnetic field over the past 2,000 years that has been observed may indicate the onset of another magnetic field reversal. The last reversal of Earth's magnetic fields was about 788,000 years ago. That was the last time the Earth was opposite. According to Hawaiian lava, 700,000 years ago, our South Pole was magnetic. It did a sudden flip. According to lava samples, before that, they had seen that it had flipped every 200,000 years. And the last time now was 788,000 years ago. So they're saying we are way overdue for this to naturally occur again. And in simulated computer models, every time the field weakened, the poles flipped. Every time when they put these facts into the computer. Coincidentally, the last full-scale eruption of Yellowstone, the supervolcano, was 640,000 years ago. And it has been actually, the floor of Yellowstone has been increasing, expanding about 3 inches a year between 2004 and 2008. It has been like swelling, which was more than 3 times greater than it has ever been observed since they first started measuring it in 1923. That was 3 times more than they've ever seen it happen, and this was all happening since 2004. In January 2010, the USGS stated that Yellowstone had slowed significantly, however, but the uplift continues, but now it's at a slower pace since 2010. So, what could be causing these things? And the scenario is also supported by observations of the solar magnetic field, which also regularly flips spontaneously every 7 to 15 years. The sun's magnetic field also flips constantly, but differing than the Earth, where ours flips when it starts weakening, the sun's increases. Their magnetic field, its magnetic field increases, and that's what precedes a flip for the sun. It's the opposite. Okay, so at present, the overall geomagnetic field is becoming weaker. The Earth's magnetic field is the weakest it's been in 2,000 years. So it was at a peak. When they started recording time, my son actually made this chart here from a movie we saw about the Ring of Fire or something. And it had peaked here in 2000. I mean, in the year 0. In the year 0, it was at its peak, and it had been like going like this, but it had actually peaked higher than it had ever been. This is the Earth's magnetic field, and then now it's actually